Welcome to section 7.1, day 1, multiplying powers with the same base. Today's objective is to multiply powers with the same base. So first, a few terms. A monomial is a number, a variable, or the product of one or more variables, and the variables have non-negative integer exponents. They can have only one term, so there's no addition or subtraction, and they have no variables in their denominators. Now recall from earlier this year, a power is an expression of the form x to the n, where x is the base and n is the exponent. And if we have x to the fifth, it means we multiply x by itself 5 times, as demonstrated below, where we have x times x times x times x times x. First we will do is identify if the following expressions are monomials. If they are a monomial, explain why. If they are not a monomial, also explain why. So is the number 10 a monomial? Yes, it is, because it's only one term. And it has no negative exponent, so it's just only one term. It's just a number. It's a constant, actually, and constants are monomials. We'll put that in here too. Constants are monomials. Next we have f plus 24. Is this a monomial? In this case it is not. Has addition. So we have to put some reason in here, and one of those things we can say is has addition. You could also say it has more than one term. And of course the reason why it has more than one term is we have addition in it. Next one we have is h squared. Is this a monomial? Yes, it is. It has one term and it has positive exponent. If it had a negative exponent, it would not be. But the variable in this case has a positive exponent of 2. The next one we have 23abc squared. This is a monomial. This is all a product. We have no addition, we have no subtraction, and we have no negative exponents. So this is just a product of variables and numbers. So this one is a monomial. The next one we have MP divided by n. This is not a monomial. Has variable in the denominator. And that would be our reason. Has a variable in the denominator. So this is one of those things you will have to do today. You will have to identify if something is a monomial or not. To multiply powers with the same base, we add the exponents. We have a to the m times a to the n, which equals a to the m plus n. Since they have the same base, we can add their exponents. And this is where a does not equal 0. Because if the base was 0, what's 0 times itself? It would just be 0. And the m and the n are integers. We're going to be doing this with just integers. We're not going to be dealing with fractions as our exponents at this point. So we have b cubed plus b to the 5th. And we just add those exponents together. So we have b to the 3 plus 5. And we get b to the 8. This is how we multiply powers when we have the same base. We just add their exponents. Here it says, what is each expression written as a single power? I want you to combine these. We have one exponent. I'm not going to have you for this slide actually evaluate them. We're just going to combine the exponents. So we have 9 to the 5th times 9 to the 3rd. And yeah, I do want to see some of this. 9 to the 5 plus 3, which is 9 to the 8th. And at this point, we just leave it like that. If it says to simplify it, we would actually, or evaluate it, we would actually take 9 to the 8th on our calculator and get a really large number. Here we have negative 3 to the negative 2nd and negative 3 to the 10th. They have the same base of negative 3. So we are going to add the exponents. We have negative 3 and we have negative 2 plus 10, which becomes, I'm going to put the parentheses around here, and you need to have the parentheses because the negative is included with the power. Because the negative is included with the base, and that whole base is raised to the power. So the negative has to be in parentheses with the 3, and we get negative 3 to the 8th power. Next one we have x to the 4th times x to the negative 1st, And we are just going to add the exponents. We have 4 plus a negative 1, which is x to the third power. So again, when we're doing the same base and we're multiplying them together, we add their exponents. Here it's asking us what is a simplified form of each expression. So we have 6b to the cubed times 3b to the negative eighth. When we do this, and we have the same base, and we have these coefficients out front, in this case we have 6 and 3, we would multiply the 6 and the 3 together. And 6 times 3 is 18. And then we have b to the third, and we're going to add negative 8. And when you do this, you get 18b to the negative fifth. And at this point, we're going to leave it like this. Later on in this chapter, we're going to learn about negative exponents and what to do with them. But for now, we'll just leave it like this. For the next one, we have 4c times 3d to the fifth times 2c cubed. So we look at first as the coefficients. We have a coefficient of 4, 3, and 2. So we can multiply those together. We have 4 times 3 times 2, which is 24. Then we look to see if we have any common bases. And here we have a c, and we have a c cubed. And if you don't recall, if we just have a c, it has a power of 1. It's not written up there as an exponent, but we do have an exponent of 1. So we would have c to the first, and we're going to add 3 to that. And we have d to the fifth, because there's only one d. And then we would add our exponents together, and we get 24c to the fourth, d to the fifth. And there is my solution, or my simplified form. 24c to the fourth, d to the fifth. Next we have x cubed y to the negative fourth times x to the fifth y squared. We have a common base here of x, so we have x to the 3 plus 5 times we have y to the negative 4 plus 2, and when we do this we get x to the 3 plus 5 is 8, and we have y to the negative 4 plus 2, which is y to the negative second. And there is my simplified form. So again, when we're multiplying these together, if we have coefficients, we can multiply the coefficients together. We look for common bases, and if we have common bases, we would add their exponents together. And like I said, we will not be worried too much with negative exponents right now. We will learn those more in a later section, what we do with those. At this point, if you do get a negative exponent, just leave it as a negative exponent. That is all for section 7.1, day 1. Multiplying powers with the same base. Thank you for watching, and have a nice day.